The graph of f of x equals absolute value of floor of x, right, minus absolute value of floor of 1 minus x is symmetric about which of the following. Here, absolute value or floor of x is the greatest integer not exceeding x, right? These little brackets represent floors, meaning like, for example, 3.4, you want the greatest integer not exceeding this number. Well, that's 3. For positive numbers, you can think of it as just taking the point, everything before the decimal point. So the integer part, basically. All right. In this case, we want to find certain types of symmetry. Here, if we take a look, we could try a couple values of x to just see what's going on. All right, so maybe we'll try some integer values of x first, so we don't have to worry about the floors. So I'm going to start from maybe -2, -1, 0, and then 1 and 2. I'll just compute it for each of these. So for integers, the floor of x is equal to x, right, for integers. So then we can just treat this like absolute value of x minus absolute value of 1 minus x for now. And that's not bad. For -2, that's absolute value of -2 minus absolute value of 1 minus -2. So that's 3, which is 2 minus 3, and that's -1. The value at -1 is absolute value of -1 minus absolute value of 2, which is -1. Right? Let's take a look at 0, right? It's going to be absolute value of 0 minus absolute value of 1, right? And that's -1. At 1, it's going to be absolute value of 1 minus absolute value of 0. That's 1. For 2, it's 1, and so on. So every integer greater than 2 will give us 1, and every integer less than -2 will also give us -1. All right? So for now, we have the following graph, okay? So here's -1, here's 1. Our graph looks like, here's -1, -2, 1, 2, right? -2, -1 is here, -1, 0, -1, 1, 1, right? Now let's take a look. Is this symmetric about the y-axis? The y-axis is here? No, because if it's symmetric about the y-axis, then these two values would be the same, right? Because of the symmetry, so that doesn't work. The line x equals 1, that would be this line. We can also see that there's no symmetry about this point because if you reflect it across here, for example, you don't get any point on the graph, right? So there's no symmetry about this point. The origin, no, because this point, for example, if we rotate it 180 degrees according to symmetry by the origin, this point would be a point on it, but it's not. So there's also no symmetry about the origin. The point 1/2, 0, that would be this point. And if you imagine rotating this 180 degrees about this point, you would still get the same graph, right? These match up, and so on. So that would work. And finally, the point 1, 0 also doesn't work because, right, the symmetry doesn't work. So the only one that works is D. And you can notice that if you plug in x to 1 minus x, so if you plug in 1 minus x here, you get the same thing, but it's switched. So you switch these two terms, which means you take the negative of that f, right? And as a result, because of this, you can see that x and 1 minus x are kind of like anti-symmetric. So if you like switch these out, you get the negative of each other. So that gives us the point symmetry about 1/2, which is, the average of these 2 points, right? So that also makes sense in the algebraic way. So this makes, so D must be the correct answer.